Hello everyone, you are welcome to this video. This is the part 2 of the theory questions 2011 waec past questions. Okay, so the first one says explain relative motion. Okay, so relative motion is the motion of an object compared to the motion of another. The motion of an object relative or compared to the motion of another. Okay, that means, or you can say the motion of an object compared to another object in another reference frame, whatever that is. Now number 2 says two cars moving in opposite direction on the same straight road with velocities this and this respectively pass each other at a point. Determine the velocity of the first car relative to the second. Now whenever two cars are moving in opposite direction, the relative motion, let me call that VR, is to add. It's going to be V1 plus V2. Okay, that's 80 plus 60, which is equal to 140. So the answer here is 140 kilometers per hour. Okay, so the relative motion between two objects moving opposite to each other is to add. But when they are moving in the same direction, the relative motion is to subtract. Right? And it makes sense such that when you're moving against a car or an object, the person appears to be faster than when you're following behind. Now the second one is define force. Force is the cause of motion. Force is what causes motion. You can also say that force is pull or push, right? Yeah, that causes an object to move from one point to another. That's what force is. Now the second one says classify the following forces as either contact force or field force. Okay, push is contact. This is contact. Tension is contact. Gravitational is field force. Electrostatic is a field force. Reaction and magnetic. Reaction is a contact force. Magnetic is a field force. Okay, so gravitational, electrostatic, and magnetic are all field forces. Okay, very important. Now the C part here says a body starts from right and travels in a straight line for 2 seconds with a uniform acceleration of 1 meter per second. It then travels at a constant speed for the same time before coming to rest with a uniform retardation of 2 meters per second. The total distance covered is 15 meters. Wow. I draw and label the velocity time graph for the motion. Okay. Then I calculate the velocity attained after the first 2 seconds. Okay. And the total time for the journey. Oh, I will need space. So already reading the question, I knew it was a velocity time graph question because it told us that it accelerated and did not stop there. It also moves the constant velocity. This is constant velocity and this is retardation. Okay, so the acceleration based on is 1 meter per second square, I guess. 1 meter per second square. And the first, that acceleration from rest is starting from rest. That's why we started from the origin. And the first motion is for 2 seconds. So that means if I trace this here from here to here is 2 seconds. Then we're also given that the total distance covered is 15 meters. The total distance covered by the motion. And remember that distance is area under the graph is 15 meters. So we have a lot of questions to answer here. The first one is to draw and label a velocity time graph for the motion. That's exactly what we've done here. It's velocity. You can put the unit, which is meter per second. Then second time you can put the unit, which is seconds, right? That is exactly what we have here. I can say that the distance s is equal to 15 meters. Okay, so this is well labeled. Now the next one says calculate the velocity attained after 2 seconds. So the velocity attained after 2 seconds, from this acceleration I can find the velocity. Acceleration is supposed to be change in velocity over time, or you can say the slope of this graph. Acceleration is 1. The final velocity we don't know. The initial velocity started from rest, so it is 0. Over the time taken to go this motion is 2 seconds. So 1 is equal to v over 2. If I cross multiply, v is going to be 2 times 1, which is 2 meters per second. So the velocity is 2 meters per second. That's quite easy. So I can just write it here, 2 meters per second. Now the next one says the total time taken for the journey. So if we want to find the total time taken for the journey, remember that the total distance, this is a trapezium, and the total distance is supposed to be half a plus b, okay, times the height h, right? Remember we just calculated the velocity now to be 2 meters per second. So the total distance is 15 based on the question, is equal to half times a plus b is the parallel side from this to this, which we don't know what it is, right? We don't know what the time is there. So from this to this, then b is from this to this, which is the whole time. I need to confirm something. Remember there is a uniform retardation of 2 meters per second. Okay, I forgot to add that. I just saw that something is wrong. So since the uniform retardation, I can say negative acceleration is equal to minus 2 meters per second square. Okay, so this is what we have here. Now the reason why this is important is so that we can also be able to calculate the time of this motion from here to here, which is quite important. And we can do that because acceleration is velocity minus, that's change in velocity over time. In this case now it is negative 2 because it's retarding. The final velocity is 0 because it comes to rest. The initial velocity is 2. That's where it started from this motion, 2. So I'm going to say 2 all over time. So negative 2 is equal to negative 2 over time. So that means t is going to be equal to 1 second. So that means the time it took to, this motion is 1 second. So I'm going to say from here to here is just simply 1 second. Right? Yeah, that's quite easy. And y from here to here is 2 seconds. Okay, so I can place these 2 seconds here. So from 0 to this 2 seconds. So here is missing. We don't know what here is. We can call it t1. We don't know what it is. Okay, and there is no other way we can use to find that. Even with the velocity, we don't know the time. Acceleration is no. We don't know how long it remains constant. So we are going to leave it at that. Okay, that is beautiful. I think another idea is coming to mind because this method is going to look quite stressful. I can come to that again. Okay. Remember that the total distance is 15 meters, and the distance, you have a triangle here, you have a rectangle here, that's 2, and you have another triangle here, that's 3. The first distance, S1, that's for the first one, is a triangle. You can say half base times height. Okay, so which is equal to half times the base is 2 because it's 2 seconds times the height from here to here is 2 meters per second, so 2. So this is 2 meters for here. Now we can also easily find S3. We don't know this yet, so we can find S3 is also the same formula, half times base times height. That means half times the base, it says 1 second, right? Because that's the distance covered here. Then multiplied by the height is 2, so this is going to give me 1 meters. You see? So if S1 and S3 is 2 meters and 1 meters, it means that S2, the remaining distance, will be 15 minus 2 minus 1, because the total distance traveled is 15. So 15 minus 2 is 13, 13 minus 1 is 12. So the answer is 12 meters. So that means the distance for this constant velocity is 12 meters. And don't forget that that distance there is a rectangle. This is a rectangle. So the rectangle means length times breadth. That means S2 is length times breadth. But in this case now, S2 is 12. The length is from here to here, which we don't know, right? We don't know what it is. So we can, and that's, we can call it, let me call it T. I can call here T1, call here T2, and call this time here T3, the space. So let me call here T2 times the base here is 2. So that means T2 is equal to 12 divided by 2, which is equal to 6 seconds. So that makes the job easy. So the total time is equal to T1 plus T2 plus T3, right? We already know what T1 is. T1 was the initial time was 2 seconds. Then T2 is what we just found now, 6 seconds. Then T3 is 1 second. So 2 plus 6 is 8, 8 plus 1 is 9, 9 seconds. Wow, the question is quite tricky. But it is important that you solve as many questions as possible. It gives you edge. It makes you know how to manipulate, whenever you encounter tough questions like this. Yeah. I'm also seeing that there is still no problem with us using this, but just like I mentioned, it's going to be a whole length of a time. Yeah, I can see that we can do something here about that. Very, very, very important. But this method I did now is better. So that is it for number 11. I will be doing the next video for number 12. Thank you.